Good morning, class. So some people were having some questions and confusion about the exponential question, uh, word problem questions that we were working with in Khan Academy. So I just wanted to get to that and go through those one by one. Everyone should have the same questions, and in order to get to those questions, you would have to be in Khan Academy, and you'd have to sign in here, okay? And so when you sign in, make sure your name is at the top, okay? And so I'm going to go to my learner home, like it's a little smaller so you can see, and you'd see my assignments and exponential word problems. And you hit start, okay? And this is going to get you back to the problem. So the problems that you are working on were here. All right. So we are going to look at this problem. So when the Dragons have lost their most recent games, fans buy 200 tickets. So we know we got 200 tickets. 200. Oh, I'm sorry. That's a 200. And for each ticket, the number of fans that buy increases by a factor of 1.1. So when something is increasing by a factor of 1.1, it means take the original number, 200 in this case, and then multiply it by that factor. So that is the factor that increases it. And so it's saying after 4 consecutive wins, how could I express that? So in this case, it would in fact be 200 times 1.1 gets you to, after 1 win, they do this. And then we take that whole thing and multiply it by 1.1 again. And then we multiply it by 1.1 again. And then by 1.1 again. It's hard to see here, but this would be your answer down here. 200 times 1.1 times 1.1 times 1.1. Another way to write that, which isn't one of our answers here, but it is what we're trying to get to in exponents, is 200 times 1.1 to the 4th power. Okay, because 1.1 times itself 4 times is also 1.1 to the 4th power. And that's what we're going to start seeing in the next problems. All right. So we're going to get rid of this stuff. Moore's law says that the number of transistors in a dense integrated circuit increases by 41% every year. This is a fancy way of saying that computers are getting 41% faster every year. And that's because that's how much circuitry they can fit in a little space. So as technology starts increasing. All right. So in 1974, we had 5,000. And then it was increasing by 41%. So what you need to do, so 5,000 is the starting. So that's pretty easy. Oops. We got 5,000 is what we start with, 5,000. And then you go times, that was terrible. And for each year, so how many years happened between 1979 and 1974? Well, 79 minus 74 is 5 years. So I know it's 5 years. So every year it's going to increase by 41%. I know I can turn 41% into a decimal by dividing by 100, and that gives me 0.41, which you see in all of these things here. But in order to do it properly, it would be 5,000 times. So I'm going to put a parenthesis. I'm going to put a little dot here for times. And it would be 1 because that gets us the original amount plus the 0.41 plus 0.41 to the fifth power. Okay, so that gets us 5 years. So it's this times 1.41 to the fifth power. So it's that times that point many times, and so it gets bigger and bigger. So that's that. All right, and if you go over here to the hints, this looks a little bit better. So you can see how it goes. So this explains it exactly. When you go to the hint, it will explain how to do this problem. And it shows that basically this is a good table that helps that in the first year, it's 5,000. In the second year, it's 5,000 times 1.0.41. Then the next year, it's 5,000 times one, like, which was the number of resistors in the first year times that, and then, and so on and so on for 5 times. And so this would be your answer. All right. Now, 3. Okay, so I'm going to go back to drawing because I don't want you to just see the answer right away. Javier bought a painting for $1.50. Each year it goes up by 1.15. Or sorry, he paid $150. So it's pretty simple. It's 150 times the factor that it's going up by raised to the power of the number of years. So because it's going to increase by this amount. So I take, for instance, if I took 150 and I multiplied it by 1.15, it goes up a bit. Let me get my calculator out. 150 times 115 gets us to, hold on, sorry, calculator. 150 times 1.15 gets me to 1 times 1.15 times, it goes up to 172.5. So that's after 1 year. So then I take that and multiply it again by 1.15. So it's basically taking this and multiplying it by 1.15 7 times. So I'll flip over to hints. So this is what it's basically saying. It's saying the same thing that I did, which is that after 2 years, you would have 150 times 1.15 times 1.15 again, and so on until you get 7. And so the answer here is A. And then finally, again, we're going to clear this. This is talking about interest rates, all right? And this is what banks do, and this is how you can make some money. Benjamin has $400 in a savings account that earns 5% each year. After 3 years, how much money is he going to have? So he's going to have 400 times 1.05, 1 plus 0.05 plus 1.05. So there's many ways to write it. This is actually the way that they've chosen, A right here. I would have written it like this. Or you guys can think of this as 400, 1 plus 1 plus 0.05 is also 400. That's a 400 times 1.05 to the third power. That's another way of writing it, but the actual way that they wanted you to do it is this one right here, A. And I'll flip over to hint. A growth rate means savings keeps their 100% and adds 5% more, so that each year the savings balance is multiplied by 100% plus 5%, which is also 1.05. 1 plus 0.05. And after 0 years, it's $400. After 1 year, it's that much. After 2 years, they take the amount after 1 year and add 1.05. Now, this is all really confusing, but hopefully we'll be able to go through it in our live lesson today. Thank you.